All right, so I think this is recorded. Let's take a look here at problem number 9. We have a square root, we have a radical equation. We always want to make sure that the radical is by itself, that that term is isolated. And to get rid of this square root, we square it. To balance the equation, we'll square both sides. So on the left-hand side, I'm going to square that. And to balance the equation, I'm going to square this on the right-hand side. So this square root symbol, this goes away. It cancels. And on the right, we have r squared. So this equation is a quadratic equation. We're expecting two solutions because the biggest exponent on any variable is 2. These now, when the two solutions could be repeats, it could be r equals 1 or r equals 1. We don't know yet. We want to rewrite this equation in standard form. Now, I have a preference towards having my leading coefficient be positive. So yes, it's true that we could subtract r squared from both sides, but then that would give us a negative r squared, and I personally don't like that. Sign errors are the enemy, and it's easy to make sign errors. And for me, if this r squared is negative, I have a tendency to make too many sign errors. So I'm going to subtract 5r from both sides, so that term will cancel, and I'll have minus 5r there. Again, notice that if you have a term and it changes sides of an equation, it changes sign. You'll see over here it was plus 5r, and now it's minus 5r. And the same with this minus 6. If I add 6 to each side, you can see that the minus 6 is now plus 6. So with a leading coefficient of 1, this makes it much easier to try to factor this problem. If we can't factor it, we can always solve a quadratic equation by completing the square, and we can always solve it through the quadratic formula. But in this case, we'll be able to factor it, because it's possible to come up with two numbers that multiply together to give us positive 6, but add together to give us negative 5. So r times r gets me r squared. And a negative minus 2 times minus 3, hey, that's going to get me the positive 6, but when I add them together, it's going to get me the negative 5. So we also have a zero coefficient theorem. If you have a product and that product is equal to 0, then at least one of the numbers is 0. So 2 minus 2 would give us a 0, and 3 minus 3 would give us a 0. So to satisfy this equation, r has to be one of these. Now, although 2 and 3 satisfy this quadratic equation, it's possible they may not satisfy the original equation, because the original equation was a radical equation. And radical equations may sometimes have extraneous solutions. So let's plug in r equals 2 into the original equation and see if it checks. So on the left-hand side, we've got negative 6 plus 5 times r, but we're replacing r with 2. Now the big question is, if we replace r with 2, is this arithmetic going to result in a 2? So we have negative 6 plus 10, which is 4, and the square root of 4 is 2. So this does definitely check, and r equals 2 is in our solution set. What about r equals 3? We've got negative 6 plus 5 times 3, and this time the big question is, does that arithmetic result in 3? So negative 6 plus 15 is 9, and the square root of 9 is 3. So yes, it checks, and both of these are in our solution set. All right, well, hey, I hope that helps, and I will talk to you later. Bye.